Welcome to the ARE 5.0 video prep series, brought to you by NCARB. In this video, we'll take an in-depth look at the Project Planning and Design division. Project Planning and Design focuses on the preliminary design of sites and buildings. In this phase of the project, you'll generate and evaluate design options that synthesize environmental, cultural, behavioral, technical, and economic issues. You'll need to understand a range of topics related to code, sustainability, program requirements, existing conditions, and other factors. You should also be familiar with how to research and select building systems and materials, and how to merge the individual pieces of a project to form a cohesive design. During the project planning and design phase, you'll evaluate the design options generated during planning to determine if the various project parameters have been met. Once you've selected the design, the project can move into the documentation phase, which is covered in our project development and documentation video. Be sure to review the latest ARE 5.0 guidelines and ARE 5.0 handbook, both on the NCARB website. The guidelines contain critical information about ARE 5.0 policies, including the rolling clock, scheduling a test, problems while testing, and receiving your score. The handbook discusses the content of all 6 divisions and includes sample items and suggested references, as well as more information on the objectives for each division. You'll have 4 hours and 5 minutes to answer 100 questions in this division. The content is distributed between 2 small sections on environmental conditions and context and project cost and budgeting, 2 larger sections on codes and regulations and building systems, materials, and assemblies, and a large section on project integration of program and systems. In the environmental conditions and context section, you'll use the site information gathered in the programming and analysis phase to plan the site and environmental aspects of a project. Let's look at a sample question. A new 1-story daycare center is being planned in a hilly suburban location in a hot, humid climate. The prevailing winds are from the south. The client wants to use passive cooling. Which of the following strategies should the architect recommend? Check the 3 that apply. The building should be located at the top of the slope. The building should be elongated along the north-south axis. The playground should be located north of the building. The building's main corridor should include operable transoms above the doors. The building should include large openings on the north and south sides. A line of shrubs should be planted west of the playground. These are the correct answers. All of these strategies are discussed in sun, wind, and light. Buildings in a hot, humid climate should be located at the top of a slope to catch cooling breezes. Large openings on the north and south sides and operable transoms in the corridor will allow for cross-ventilation. A north-south axis would actually limit the opportunities for cross-ventilation and expose the building to the hot afternoon sun. Placing the playground north of the building would provide limited shading but would block cooling breezes from reaching the playground. Planting shrubs west of the playground may provide visual interest but would not be effective in blocking the hot afternoon sun. This is an AE level item requiring analysis of existing site conditions and passive cooling strategies to determine what's most appropriate for the given situation. In the next section, you'll look at the codes and regulations relevant to the planning phase of a project. Let's look at a sample question. An office building is proposed for a rectangular suburban office park site measuring 300 feet by 600 feet. The program requires an uncovered grade level entrance plaza of 30,000 square feet, a 120,000 square foot below grade parking garage, plus 450,000 gross square feet of office space. Setbacks must be free of built site improvements. What is the minimum total number of parking and office levels needed if the city requires a 20-foot setback on all sides? The correct answer is 5. You'll first need to calculate the buildable areas. The below-grade buildable area equals the surface area of the site reduced by the required setbacks. The above-grade buildable area equals the below-grade area reduced by the required plaza. Next, you'll calculate the number of levels required to accommodate the office space. This can be found by dividing the total office area by the above-grade buildable area. Finally, you'll calculate the number of levels required to accommodate the parking garage, which is found by dividing the total parking area by the below-grade buildable area. Remember that all partial levels should be rounded up to the nearest whole number. Add the above-grade and below-grade levels together to find the total answer. This is a UA level item requiring an understanding of zoning setbacks and building massing. In the Building Systems, Materials, and Assembly section, you'll focus on other disciplines with which an architect must be familiar, along with the various components that make up the building. Let's look at a sample question. The client for a new mid-rise office building desires a mechanical system that will have minimal operating cost and maintenance, allow maximum flexibility for office space layout, and provide individual control over the interior temperature. Drag the labels and symbols from the area on the left onto the schematic layout of the recommended system on the right. Not all items will be used. The single duct variable air volume system, as described in the Architect's Studio Companion, meets all of the client's requirements. The fan room is the central hub for the system, conditioning the fresh air before distributing it through the building. Cooling is provided by the chilled water plant, which requires a cooling tower. Heating is provided by boilers, which exhaust through the chimney. Finally, each conditioned space requires a VAV terminal with a thermostat, providing both flexibility and temperature control within individual spaces. This is an AE level item requiring analysis of the client requirements and an evaluation of system options. In the Project Integration of Program and Systems section, you'll pull together all the decisions from the previous 3 sections regarding environmental conditions, code, systems, and assemblies. This is the largest section in the Project Planning and Design division. Let's look at a sample question. This plan shows a new community center planned for an existing apartment complex. The community center will include 4 main program areas with the following requirements: leasing office near main entrance, multi-purpose room near pool deck, exercise room near restroom/locker rooms, restrooms/locker rooms near pool deck. Each program area will occupy 1 quadrant of the building. Click in the quadrant that is the most suitable location for the exercise room. The correct answer is the northeast quadrant of the building. By reviewing the site plan, you can see the locations of the main entrance and the pool deck. Based on that info, you can then determine the locations of the various program spaces given the listed requirements. The multi-purpose room and the restrooms/locker rooms must both be on the west side of the building. The leasing office goes in the southeast corner of the building in order to be near the main entrance. This leaves the northeast quadrant for the exercise room location. This AE level item requires you to evaluate multiple pieces of plan and program information to provide an acceptable solution. In this last section, you'll consider the bottom line, asking the question, how much does this project cost? Let's look at a sample question. The mechanical engineer has proposed 2 different HVAC systems for a new project. Either system is suitable for the project type and location, but for tax purposes, the owner prefers a higher HVAC equipment depreciation cost over the life cycle of the system. System A is a forced air heating and cooling system with an upfront cost of $10,000, an anticipated useful life of 20 years, and a salvage value of $1,000. System B is electric package terminal units with an upfront cost of $7,500, an anticipated useful life of 15 years, and a salvage value of $1,500. What is the annual depreciation of the system with the higher per year depreciation? $300, $400, $450, $500. The correct answer is $450. Annual depreciation value is an important aspect of life cycle considerations. It can be determined by subtracting the salvage value from the initial investment, then dividing by the estimated lifespan of the system. Based on the results of each annual depreciation value, you determine that System A has a higher depreciation of $450. This is an AE level item requiring an appraisal of life cycle costs as applied to mechanical systems and a comparison between the costs in order to recommend a system. Ready to get started? Refer to the ARE Handbook for a list of reference materials most often used to develop the questions included in this division. This is not an exhaustive list of all possible references, but a suggestion for further reading. And remember, lots of people are studying for the ARE right now, so join the conversation. You can stay on top of the latest news and connect with NCARB and your colleagues with these sites. Be sure to check out our ARE community created just for ARE 5.0 and take a look at our other ARE 5.0 division videos. Thanks for watching.